Right. Let's continue with lesson 3, video 2. So let's look at example 10 now. Determine the inclination of the straight line 2y plus 3x equals to 5, correct to 2 decimal places. So at the moment, the equation is not in standard form, so that is what we should do. Rewrite in standard form. Why? So that we can see what is m, isn't it? Because that is the idea. I want to see what is m. Once I have m, I can say the tan of theta. Cool. So take the 3x over and then divide by 2. So there you are. So the gradient is minus 3 over 2. So again, people, it is a negative. So I need my reference angle. So for the reference angle, shift n, right? And then we use a positive 3 over 2. Please be careful. Positive 3 over 2. Don't do the negative. Negative is telling you which quadrant. So therefore, I get 56,309. So we normally round off to 2 decimals. So I would say 46,31. So 56,31 is your reference angle. So theta is therefore 180 minus 56,31. And that gives you 123,69. Are we okay with it, guys? Cool. Next example, 11. Determine the equation of a straight line with inclination 135. And it passes through point 3 and 2. Oh, now they give you the angle. What you should do is, you again start with the formula that gradient is tan theta. So what is the tan of 135? Well, let's see. The tan of 135 is negative 1. Now, a negative gradient should tell you in which direction. Is a graph, a line like that, a decreasing function. So there's your formula. Remember the formula y minus y1 equals to mx minus x1. So m is negative 1, and the other point is 3 and 2. So 2 goes there, so that's y value. And of course, 3 goes there. Right, there. Right, remove the bracket, and you get your answer. Y equals to negative x plus 5. Cool. Now, the angles between two lines. Now we can have two graphs. So the situation is a bit different now, because now I'm dealing with two graphs. So the angle of a line is the angle between the line and the positive x-axis. We may, however, use any horizontal line instead of the x-axis. Like I've done it also early on. I can use any horizontal line. It doesn't have to be the x-axis itself. In order to calculate an angle between the two lines. So this is what we want. Angle between the two lines. So that will help us a lot. And the formula is, we call it alpha. We call this angle alpha. So what you do is, gradient of the first line minus gradient of the second line. So it's the bigger gradient minus the smaller gradient. Let's look at the first example quickly. Example 12a. So this is the one line and there's the other line. You see, guys? So I need this line's gradient and I need that line's gradient to find alpha. See, guys? So if you look at the solution, right, there's a solution. So start with this angle first. This angle here, you all see it? Let's call it theta 1. Right, call it theta 1. So the gradient is 1. You agree with me? The gradient is 1. So it is 1 shift 10, so it is 45. So this angle here is 45 degrees. Then you take the other one, which is there. Can you see it, guys? This is another color pen here to show you. So this is the other angle, right, like that, which is theta 2. And that gradient is this line. Remember, this line here, y equals to minus 2x plus 3. So the gradient is minus 2. So there, I must first get the reference angle. So the reference angle will be shift 10 of a 2. So let's see, shift 10 of a 2, shift 10 of a 2, and it gives us 63,43. 63,43, which you must subtract from 180. So theta 2 minus 63,43, and that will give you get 116,57. This one here. Clear, guys? So now I have 45, I have this angle, so I subtract the 2 and I get 71,56. Angle between the two. At end of video 3. Sorry, I mean end of video 2.